subtraction. All right, here we are in West Virginia again. I'm really struggling with this. But what I don't struggle with is joke of the day, because you know it's the best part of the day. Are you ready? Let's do this. So, you know, I used to have a fear of hurdles. You know, like track hurdles, you know, running over track hurdles. I used to have a fear of hurdles, but then I got over it. Track people will understand that because you jump over hurdles and you get over it. Oh, anyways, let's get over on to taking a look at fractions. So we've taken a look at how to get equivalent fractions. We've taken a look at what a fraction is. We've taken a look at equivalent fractions and how to simplify fractions. So now let's take a look at this concept of being able to put fractions together or take them apart. So the idea of adding and subtracting fractions. So we've got a couple of different types of adding and subtracting situations that we can deal with. With the kind where we have a common denominator and the kind where we don't have a common denominator. Now remember, the denominator is the bottom of the fraction. So in this case, the denominator here would be 5 and 5 in this case. And in these two fractions, the denominator would be 4 and 4. You can see that these are the types of fractions that have those common or like denominators. I always like to say, hey, I like it when things are alike, and I don't want to mess that up. So when I have a common denominator, I want to keep that denominator because the denominator is the superhero of fractions, and I don't want to mess with him if I don't have to. So let's take a look at this idea of the common denominators and what happens when you put the fractions together and add them, or when you take them apart and subtract them. And that'll lead us to the steps for adding and subtracting fractions that have common denominators. So let's take a look at the first example that says I have 3/5 plus 4/5. Now in these examples I am going to add or subtract, and then I'm going to simplify. Remember, simplify means I'm going to simplify it to its lowest terms, and remember that is not the idea of shrinking the fraction. I'm not reducing the fraction. I'm simplifying it. In other words, that number that's on the numerator, the number that's on the denominator, I want them to be as small as possible and yet have the same value as the answer that I have. So if I have 3/5, and let's take our 5th pieces here, and I've got 3 of them sitting there. I want to add to that 4 more fifths. So I've got 1 here and I'm out of them. I love my little fraction pieces, but I don't have enough of these. So I'm going to do 1, here's another one, 2, here's another one, 3, here's another one, 4. Now I'm putting them all together in one pile in front of me. You can see they're all sitting here in one pile. So how many fifths do I have? Being that the 5th is the type of slice that I've got, how many of these do I have? Well, I have 1, 2, 3, 4, 5, 6, 7 of these fifths. So in other words, my answer is going to be 7 of those 5th pieces. So what that leads me to believe is, okay, when I'm going to add these fractions, it appears that I'm just simply going to add across that numerator, and I'm going to keep that denominator because the denominator is telling me the type of slice that I've got. And if the type of slice is the same all the way through, then I'm just going to keep the type of slice. Now remember, it does say that I'm going to simplify, so I want to shrink it now. Remember, not really shrink it. I'm not changing the size of it. I'm just simply going to make sure that that numerator and that denominator, that there are no numbers that are common to them that I can divide into each one of them. That was the idea of the equivalent fraction. I'm going to divide my numerator and my denominator by the same number. So is there a number that I can divide into both the numerator and the denominator other than a 1? Because when I divide each of these by 1, I'm not changing a thing. So is there a number that will divide into both a 7 and a 5? No, not at all. So this is a simplified fraction. Now, if the directions do not say to turn it into a mixed number, then I would be done here. But what if the directions did say, okay, turn them into mixed numbers? Remember, mixed number means the bar indicates division and I always divide up. So what I would do in this case is I would say, okay, the 5 divides into the 7 one time with a remainder of 2. And remember, we put our remainder over our divisor, that superhero of fractions that I'm going to keep that denominator. And 1 2/5 is the equivalent of 7/5 because 5 times 1 is 5 plus 2 is 7. That gives me my 7/5. So like I said, it appears that the steps are, let's just keep that denominator as it is. Let's work those numerators. So let's take a look at the subtraction problem and see if that is in fact the case. So I'm going to remove these fifth pieces. I'm not going to use those right now. So now let's take a look at this idea of 11/4 minus 3/4. Well, I don't have 11/4 in front of me, but what this indicates is me that I've got 1, 2, 3, 4, and then I'm going to have another one, 5, 6, 7, 8, 9, 10, and there's number 11. So this says that I'm going to take all 11 of these fourths, I'm going to take out of my pile, that's what's in my pile, I'm going to take out of the pile 3 of these fourth pieces, take out 3/4. So if I take out 3 of them, 1, 2, 3, then how many of those fourth pieces are left? Well, I have 1, 2, 3, 4, 5, 6, 7, 8 of those fourth pieces left. So that would mean that my answer is going to be 8/4. So it does appear that the rules that I said would govern how to add and subtract when I have that common or like denominator does hold true. So in other words, my rules are that we like the denominator so keep it. Keep that common denominator. We like it when things are the same. And all we are going to do is add or subtract the numerators. And there you have it. To add and subtract when you have a common denominator, 2 steps. Keep the denominator, the superhero of fractions. Don't mess with it when it's alike. And just add or subtract those numerators. Now notice here I do need to simplify. And remember, we divide up. 4 goes into 8 2 times. Now, even if we didn't have to turn it into a mixed number, because 4 goes into 8 evenly as 2, we need to go ahead and call that a 2. And notice that that does fall in line with what we see right here. There is no remainder, so it's just a 2. And you can see that if I put all these together, I have 1 whole pie. I would put all these together just like this and do the very same idea and have 1 whole pie there as well. And so that sure enough would give me my 2 whole pies. So there are the steps whenever you have a common or a like denominator. You like the denominators the way they are, keep them, add or subtract those numerators. Now let's take a look at what happens whenever you don't have that common denominator and that slice of pie is different. When the slice of pie is the same, things are pretty easy. But notice when the slice of pie is different, we've got a problem here. This says 3/4. Let me get my fourth pieces again. So here are my 3/4, and I'm going to add to that 2/3. Now hold on a second. 2/3 would indicate this. Those are not even the same type of slice. So if I try to put them together, and here's those 3/4, and I try to add into that the 2/3, notice that's just not working out really well. I definitely need to have that same type of slice. This is why we need those common denominators. This is without, I need a common denominator. So what I need to decide is what type of slice would be the same for both of these, that it would make this and this have the same type of slice. Now notice with these fourth pieces, I can certainly turn those into 8s, because you notice that with the idea of equivalent fractions, I can turn each of these fourths into 2 8s. That works great. But in terms of trying to get the same type of slice, if I put that 1/8 on this third piece, notice that it's not going to work because this 1/8 is too big. If I set it up like this, there you go, you can see a little bit better. The 1/8 is too big for that. So that's not the same type of slice. Now with the thirds, I can certainly turn the thirds into 6s, because there we go. 1/3 is the same thing as 2/6, but if I try to take my fourth pieces and I try to turn them into 6, once again, it's not going to work because you can see here that 6 is entirely too big. Let's put this fourth over top of it, and you can see very clearly, no, the 6 pieces are way too big. So the 6th is not the type of slice that I'm going to be able to use to make them equivalent. But what about perhaps a 12th? Because if I put 12ths on these fourths, aha, that works beautifully. 3/12 is the same thing as 1/4. The idea of equivalent fractions. I would take my numerator of 1 and multiply it by 3. Take my denominator and multiply it as well by 3. 1 times 3 is 1, 2, 3. 4 times 3 is 12. That would give me my 3/12. But notice that these 12ths would as well work for the third. Because 1/3 is going to be the same thing as 4/12. It works beautifully. So my common denominator here is going to be 12ths. So what I'm going to do is I'm going to take this 3/4 and I'm going to turn it into 12ths. I'm going to take my 2/3 and turn it into 12ths. Now notice, here's where people mess up. I'm trying to find the smallest number that each of these will go into. 4 goes into 12. 3 goes into 12. I am not looking for the smallest number that will go into them. That's the mistake that people make. They try to find the smallest number that will go into each of these. No, 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 no. As you can see here, when I was trying to get that common denominator, I was trying to get the equivalent space, the same value, the smallest number that these two will go into. So 4 goes into 12 3 times. Multiply this 4 by 3, and we've already looked at this idea of equivalent fractions. That means multiply the numerator by 3. Once again, reminder, that's because 3 over 3 is just a 1. And so when I multiply 3/4 by 1, I am not changing value at all. In other words, 3 times 3 being 9, 9/12 is the same thing as this 3/4. And you can see it beautifully as I put my 12ths in here. And there's 6, and here's 7, and 8, and 9. Yes, 9/12 is in fact the same thing as 3/4. So now I'm going to take these 2/3 and turn them into equivalent fractions as well. Well, those 2/3, when I multiply 3 by 4 to create the 12, then that means multiply this 4 by 4 to create the 12. So that means that 2/3 is the same thing as 8/12. And you can see, sure enough, that when I try to cover these thirds with my 12 pieces, there we go, and I'm just going to steal that from there, and I'm going to steal a few more here, just to prove the point. There we go, and you can see, yes, in fact, we have 8/12 here. So we had 9/12 here, we have 8/12 here. Now that we have those common denominators, we can go ahead and add them up. So that with the common denominator, we just learned, that means keep that denominator. We like it that they're alike. That's great. We worked hard to get the common denominator. You worked hard for that. So keep it and just simply add the numerators. 9 plus 8 will give me 17. So it appears that the steps for whenever you don't have that common denominator are to get the common denominator, find the smallest number they will both go into, make the adjustments, and then go back to those common denominator rules. Now remember, we do need to simplify. That means I'm looking for the same number that will go into both of these to, quote, shrink it, but not really shrink it. I'm not changing the value, just the looks. I want these two numbers to be as small as possible. So I'm looking for the number that will go into both of these. The only thing that will go into both a 17 and a 12 is a 1. So I can't simplify it. And recall that if I'm supposed to turn it into a mixed number, I will divide up. 12 goes into 17 one time with a remainder of 5. Put that remainder over the divisor. So 1 and 5/12 is the same thing as 17/12. All right, let's take a look at a subtraction problem, and then we'll settle into these steps. So the subtraction problem says, I'm going to take 1/2, and I'm going to take out of this 1/2 2/5. Starting with a half, take out 2/5. But the problem is I don't have 2/5 to take out. So what I need to do is that idea again of the equivalent denominators, the equivalent slices. so that I can pull those 2/5 out. Now, if I try to turn that into fifths, it's not really going to work very well because you can see that 1/2 does not make fifths at all, because what I have here, 3/5, 2/5 is not enough. 3/5 you can see is entirely too much, so I cannot turn that half into fifths. I'm going to need something other than fifths. So here again is that idea like we saw here, the smallest number that they will both go into. So as I look at a 2 and a 5, both of them will go into a 10. So what if then I turn this 1/2 into tenths? Here we go. So 1/2 is the same thing as 5/10. So what I'm going to do then is, in order to turn this into tenths, let me slide this over so I can work with it a little bit better. There we go. Turn each one of them into tenths. So I'm going to multiply this by 5 and this as well by 5. Because remember, 5 over 5 is 1. I'm not changing value when I multiply by 1. So this is 5/10. And sure enough, you can see that was 5/10. Now what I'm going to do is I'm going to say, okay, I still can't take 2/5 out of that. I don't have 2/5 here. I only have tenths. But that 2/5, I can turn it into tenths because I can see that 2/5 right here would be the equivalent of 1, 2, 3, 4/10. And sure enough, if I was to turn that into that common denominator and say that 5 times 2 will give me 10, 2 times 2 will give me 4, absolutely, there it is. 4/10 is the same thing as 2/5. So now what happens here is, remember, I'm not adding, I'm subtracting. So I'm saying start with this pile right here of these 5/10, take out 4 of them. So take out 1, 2, 3, 4 of them. What am I left with? I'm left with 1/10. So 1/10 is my answer. And once again, it goes back to what I said I thought was going to be the rules, the steps, the process for doing this. And that process was get that common denominator, and once I've got it, go back to the common denominator rules, which say, hey, I like having a common denominator. I worked so hard to get it. I'm going to keep it. And I'm just simply going to work those numerators. 5 minus 4 gives me 1. Remember, always simplify your fraction, but 1/10, there's nothing more that I can do with that. It is as simple as it's going to get. So let's take a look at those steps and let's formally write them down so that we've got them in our hip pocket and we can memorize them and we can run with this. So the steps for when you don't have a common denominator are obviously get that common denominator. Get the common denominator, which we lovingly call the LCD. LCD being least common denominator. So in other words, to get that common denominator, I want the smallest number they both go into. Now, once I get that common denominator, what I'm going to do next is I'm going to adjust those numerators. And then the last step, I didn't leave myself very good room here, but that's all right. I'm going to squeeze it right here. The last step is to go back to common denominator rules. Go back to common denominator rules. And that's it. So if you've got your common denominator rules, when you don't have a common denominator, it's pretty easy. It's just 2 steps to adjust and get the common denominator, then go back to what you've got. And remember, to adjust and get the common denominator, I want the smallest number they both go into. That's how you get your common denominator. Now, I do want to point out, notice that here, to get the common denominator, what happened was we multiplied these 2 denominators together, and the same thing happened down here. That's not always going to be the case. That's just coincidental right here, because sometimes the number that you're looking for, if you multiply the 2 numbers, you're going to get a denominator much bigger than what you need. Let's say, for instance, and I'm going to erase this just to give me a little bit of space here. Let's get number 2 out of the way, and let's put a third one in here. let's say that I have, for instance, a 1/10, and I'm going to add to it a 3/20. Now, in this case, it would appear that if I go by these rules and I multiply 10 times 20, I'm going to get 200 as my common denominator. Very, very large number. Now, if I do that and I get 200 as my common denominator, then I'm going to multiply this by 20 and this by 20, giving me 20 over 200. I'm going to multiply this by 10 and this by 10, giving me 30 over 200. And then when I add the two up, 20 and 30 will give me 50 over that common denominator of 200. And now I'm looking for a number that will go into both of those. The number that will go into 50 and 20 is 50 itself. 50 goes into 50 once, 50 goes into 200 4 times, simplifying it to 1/4. But remember, the point I'm trying to make here is you don't always multiply these two together. I want the smallest number they'll both go into. Well, 10 will go into 20. 20 will go into 20. Watch what happens if I go with the smallest number they'll both go into. Chances are pretty good I won't even have to simplify. Now, sometimes you do, but not always. So if I go this way, multiply that 10 by a 2, multiply that numerator by a 2, I get a 2 out of 20. Here, 20 is already there, so it's a 3 over 20. So now I have 2 over 20 plus 3 over 20, and we said keep that denominator. We worked really hard to get it. Add the numerators, 2 and 3 giving me a 5. Now, what number will go into both those? Like I said, it won't always guarantee you don't have to simplify. Sometimes you do, and we do in this case because 5 goes into 5, once. 5 goes into 20 4 times, getting the very same answer. So again, my point is, to get the common denominator, you don't always multiply the two denominators together. You want the smallest number they both go into, and that makes your life a whole lot easier. So I hope this helps with the idea of adding and subtracting fractions with a common denominator and without a common denominator. Have a great day.